Now, not that this is so relevant in winter, but we all do like to stay cool, and particularly having our cars cool. Can I introduce you to John Benson from Davies Craig, a well-known name in this area. John.
Don't feel nervous. I'm about as nervous as Donald Trump standing behind the Queen today. Why did I bring you into the conversation already? First of all, thank you very much for the opportunity to talk to you. My name's John Benson, Sales and Marketing Manager at Davies Craig. For those of you who don't know who Davies Craig is, just a brief history. We've been around just under 50 years now, started by Davies and Bill Craig. They basically started the same way as I guess all of us started. A couple of young guys with a E.H. Holden decided they wanted to make it go a bit quicker. Back in the 60s, the only way you made it quicker was to probably change the carburetor or maybe just take the fan blade off the engine. So that's exactly how they started. Then realised, well, this is all pretty good when you're going along, but when you stop, she gets a bit hot. So they then developed the thermatic fans. And they've evolved over the years. Some of you have still got, we still get phone calls for the metal ones, for God's sake. But that goes back a fair while. But we don't make metal ones anymore. We certainly make a fully, that's an Australian produced product. Where the only thing we do have to import is the pancake motor, which comes in from Panasonic in Japan, a reputable company. So we're very proud of the association we've had with Panasonic all those years. The shrouds and the blades, everything's moulded here in Australia, or here in Melbourne actually. So basically we're pretty proud of the fact that it's an Australian product. We offer the specifications and the dimensions of all our fans, are all available. The brochures are here. We make no secret of what the CFM is, which is pretty important when you're putting a whatever size fan to a say a 3 or 4 core radiator. It's pretty important that it's actually going to pull the air through. Some of the Chung Bong fans won't pull the hair off your head, so you've got to be a bit careful what you buy. They all look the same, but they don't perform the same. And it's important that they do perform the same as the specification, whether you're taking a fan clutch off and putting an electric fan on, or whether you're just replacing an electric fan, factory fan. It's important that it's going to have the same CFM, or certainly stronger CFM as than the one you're taking off. So that's fairly important. Back in, I guess 20 years ago, we decided to, basically, we'd done all the work we could conceivably do on thermatic fans, and it was decided to look at the water pump area of the car and try and streamline the coolant flow and make it a little bit more consistent, rather than have it going up and down with the throttle on with the accelerator. So we designed the EWP80, which we've got here today, and it basically, the background to that was the company took a 6-cylinder Holden and 6-cylinder Ford engines. It was predicated on the fact that they did all the tests with the CSIRO, and at that stage, the maximum amount of flow that was required was about just about 80, 81, 82 litres a minute. So that's how we then built the 80-litre pump, and that's the one that's been the one that sort of led the way. It's still our fastest selling and highest selling fan, not only in Australia but around the world. We've got distributors in America. We've got huge distributors, or 4 big distributors in fact, the UK is our biggest market, surprise, surprise, coldest place on earth, and they sell more water pumps than America does. But that's only because I don't know, Tom probably couldn't build a car, I suppose, I don't know. I probably shouldn't say that too loud. Probably a few English gentlemen here that'll probably barbecue me after this, but good luck to you. My heritage is probably, I'm a bit of a German car man. I've got a bit of a hybrid. I've got a 550 Spider with a 2.5 litre Japanese Porsche engine. I think they call it a Subaru engine, flat 4, with a Davies Craig 130 electric water pump and a 14-inch high performance fan on it. So it skips along pretty well. So I guess we've cut our teeth on, or certainly I have on that. That's been a bit of a project over the last 4 or 5 years. And as I think as John said, I went to SEMA and fell in love with one of these things and came home with a bloody empty checkbook, but that's another story. I didn't even share it with my wife, so that went down like a lead balloon at home. And I'm still married to the same woman. So, moving on. After the development of the 80, clearly and I guess with the evolution of high horsepower engines, 4.5 litre, 5 litre V8s, and of course there are 7 litre V8s, and then of course increase in horsepower. Obviously a lot of those engines now look to having an increase in flow, increase in pressure, so we developed the 115 litre water pump, and that's available in both nylon and alloy. They've been very, very good sellers for us. We actually sell a lot of the nylon ones into the marine application because of marinised internal combustion engines, so they use them in boats. And then of course, about 8 years ago, we decided we saw the opportunity to try and go up to, well, I guess address the American market. And as John said, you go to SEMA and you see all sorts of things, and you see all sorts of electric water pumps. You know, we saw some billeted electric water pumps that supposedly gave you 55 gallons a minute. Well, we couldn't get 55 gallons a minute out of the ones we got. We brought them home and tried them out. We got about 35, 40 out of them, so I'm not sure what gallons they use in America, but they're not the same as ours, Imperial or US, but anyway, take your pick. So even whether it was US gallons or Imperial gallons, we certainly couldn't get that out. But anyway, we developed the EWP 150, and there's one of those here, primarily for 5 litre and above engines, and that's been a real winner for us. That's now starting to creep up to being one of the fastest selling electric water pumps we've got. And again, I can very proudly say that these are all produced here in Melbourne out of our Altona factory. The shells we have to get made. They still use a Panasonic motor. The impeller's made here, 66 nylon glass, which is pretty strong. Good for 130 degrees C, so if your engine gets that hot, you're in trouble. So from our perspective, we're very proud of that. We're looking at a lot of other things. The one thing that we have developed over the last 10 years has been the digital controller. Some of you may have had the old analogue controller when they first came out back in, I guess 2000, about 2000, 2001. That was an old analogue. It's a bit like an old analogue phone, you know. Progress requires that you move on to digital, so we moved into the digital area, and then of course we moved into liquid crystal display digital controllers, and then of course it basically becomes, or this one that we've got now is a little bit like an engine management system. It'll control the flow commensurate with the engine temperature, and as some of you are probably observing there at the moment, it'll run there's an algorithm that basically that we set when we produced the electric water pump, that we developed this algorithm that worked out exactly how many litres per minute or what the flow rate was required in a car when the engine was cold. When it got to minus 20 degrees of the targeted temperature, basically it was 10 seconds on and 30 seconds off till it got to minus 20 degrees. 10 seconds on to minus 5 degrees, it was 10 on, 10 off, 10 on, 10 off. At minus 5, at that stage it's running at 6 volt. At minus 5 it ramps up to full 12 volt. Keeping in mind it's only drawing 10 amps out of your alternator, by the way, when it's running flat out, so it doesn't draw a lot of current. So you can appreciate, which was another very vital important criteria to ensure that we weren't going to drain the alternator. Basically, well, we might have been trying to just increase the horsepower, increase the performance, because a mechanical water pump will take, if it's somewhere between 7 and 10 horsepower to drive. So as you can appreciate, if you can actually move that from being mechanically driven to electric driven, that's basically the cheapest form of horsepower you're going to buy. I can assure you of that, and that's a very conservative figure. Does this thing still work? Hello. I'm talking to myself. I do it often. I probably don't need it. Oh, did I switch it off? Did I? Hello. No. Hello. 10, 9, 8, 7, 6. Was my time up? Was that the cue? Was that the cue? Cheers, mate. I love the subtlety here, it's great. We didn't want to. No. It's all right.
Just keep going.
Keep talking. Show you the slide. I can show you the slide presentation, but you won't be able to hear me.
No, we can hear you.
We can hear you. Right, I'll keep going. What was I up to?
Horsepower.
Basically, there you go. Well done. Yeah, essentially, we tested EWP 80. We'll start again. We had a 5 litre V8 Holden that we put on a dyno. We tested it, took all the dyno figures, basically ran it for as long as we could, because Holdens, you've got to run them, you can't run them too long. Anyway, we then took the mechanical pump off and put an electric pump on, and the torque curve and the horsepower graphs were quite extraordinary, but at that we actually got 17 kilowatts out of that, which was quite extraordinary at about 3,500 revs, which is about when you consider that the mechanical pump is absolutely working its backside off. There's never been a mechanical pump built, and I could stand to be corrected if someone can tell me in this room there's a mechanical pump that's been built that'll actually be efficient at 700 revs when you're idling, or at 3,500, 4,000 RPM when you're going flat out. It just doesn't happen. It's not built. I mean, if you have a look inside most water pumps, and I'd say looking around the room, a few of us have seen inside a couple of water pumps over the years. They're just a bloody tin plate that's you could drive a horse and cart down the end of it and down the side of it. And basically what it does, the water just spins off the edge of it. And when you slow down, it just picks up again and just keeps on going. But you've got I guess at that stage, you've got a radiator and the coolant still circulating through the car, so it's keeping the engine cool. But it does generate a reasonable amount of air as you're driving along, and not that you're likely to see it. But as long as the engine stays cool, then that's one of the things that you just don't even consider. But it's certainly something that we've looked at when we've been testing mechanical pumps, especially when you run them up to maximum revs. They certainly don't perform as well as an electric pump does at the varying rates, which is what we do here. So looking at we've got, apart from electric water pumps and digital controllers, we've now manufactured a number of adapter plates for certainly the Holden 253, 308, 304, 308, Chevrolet small block, big blocks. We've now just finalised the Windsor. We've got the LS series. We've just finished, and we're just tidying up a few things on that. That's just about ready to. In fact, it has gone to market, but we've now developed another plate, a single plate instead of the two inlets and the two inlets out of the block, left and right hand side of the block. Ford Coyote, we've developed and fitted one of those. That's going pretty well. And the Clevo, we've just finished one for the Cleveland engine. So, and we've got a couple of other. We're just looking at, as long as you don't tell anyone, within the four walls of this room, we're looking at Bluetooth, the Bluetooth operation of a digital controller, whereby it'll operate you can set it and forget it inside the vehicle, or control the temperature from inside the vehicle, and control the flow of the coolant inside the vehicle, or the water pump, I should say. And that's a bit of Bluetooth technology, so you won't have to poke wires through the firewall of the car. So no, look, we're not standing still. As I say, we've been around for just under 50 years, and we hope to be here for another 50. Probably be some other poor bugger standing up here in 50 years' time telling us some other stories about. It certainly won't be me, but I've thoroughly enjoyed my time with Davies Craig. In fact, it just ticked over 10 years. We've had a wonderful journey. It's been a wonderful journey. The export market, as you can appreciate, is very, very important to us. We go to SEMA, we go to PRI. They're very important shows for us. You just got to remember, as much as we love Australia, there's only 25 million of us sitting in the middle of the Pacific Ocean here. And while we're all asleep, there's 3/4 of the world are up and about and awake. So, and 350 million in America, and they've got as many cars in California as we've got in the whole of Australia. So, you've got another 49 states to go. So it gives you some idea of of the market that is out there. There's 9 different segments or niche markets in the US. We talk about restoration, that's one very big market. Hot rodding is one very big market, but of course you've got drag racing, circuit racing, street cars. The list just goes on, and if you've got time, if you get the chance to go to a place like SEMA, you'll see just the enormity of how big the market is. But look, that's enough from me. I've said more than I probably need to, but more than happy to answer any questions. As I say, we've got some product here. There's some brochures here that you can take away. My business card's here. Please don't ring me. No, that's a joke. No, you're welcome. You're welcome to call. We take phone calls, unlike some companies around the country. But we've also got a very, very up-to-date website. There's a lot of blogs on there. There's YouTube videos, frequently asked questions. And as I say, if there's something there that we haven't answered, then please just jump on the telephone and give me a call.
Questions for John?
Yes, sir. Fire away.
6-volt fans.
6-volt fans.
Why don't you make them?
Well, you can run a 12-volt fan at 6-volt. 12-volt fan will run at 6-volt. You're just going to lose a little bit of CFM. And if it's going on a 6-volt car, I'd be very surprised if it wouldn't do the job. If it doesn't do the job, I'll take it back.
Never tried it, but...
Well, there you go.
There is
some things in life that are worth trying.
There is somebody in
And that's
the
one
US.
of them.
There is somebody in the US that makes 6-volt fan motors, but,
Good luck to
but
them.
they're not readily available.
Oh, well, I wonder why. How many 6-volt cars, how many people got a 6-volt car in this room? There you go. All right. Well, you've all... No, please. That doesn't change our result. We won't be building any 6-volt fans. As long as my bum points to the ground, we'll be supplying 12-volt. And you're more than welcome to try 12-volt fans.
You're only working on modern cars.
No, we're not.
Yes, you are.
Well, you might. Go ahead.
With your comment earlier about CFM, do you find are your fans designed for more static pressure than just pure flow? Or do you have some vendors that are and say, we've got high CFM?
Well, okay. Let me answer your question this way. We supply all the graphs of the fan. They're all listed on the website. They're all listed in the book. You're welcome. I mean, I think you'll find that hopefully that'll answer your question. If you have a look at the CFM of the various fans, I'm not sure what size you're talking about. They're all different, obviously.
Yeah.
I'll work my way back.
What's the life expectancy of one of those electric
With a digital control, 7,000 hours, which in OEM life is 10 years. So that's what they expect. That's what they expect out of it. But the other thing I should mention is we do have, we are looking at brushless motors at the present time, but we just can't find a brushless motor that's got the shaft torque that'll actually drive the impeller. We can put them into, we've had them onto the test bed, but they actually work. We just can't keep the damn thing sealed, so it's a bit of an issue. And as soon as you get any moisture in a brushless motor, it doesn't like it that much. So you go ahead.
Do you do a blanking plate for the Chrysler Hemi 6? As you
No, we don't, but there are people around that do it. What I should, that's a very good question. The answer's no. But let me say this much: we have a number of people that have actually converted or taken the guts out of a impeller out of the blank water pump. Unless you push for space, our recommendation would be you can just gut the existing mechanical pump, because the electric water pump, which will bolt onto the bottom radiator hose, which I didn't point out.
Right, just use it as your...
Just use that as it'll push it through the engine.
Take the impeller off.
Take the impeller out of it, and the electric water pump on the bottom radiator hose will drive the coolant through the engine. Oh, there's a couple over here. There's a question over here. Is it 6-volt fans you want to talk about? Oh, sorry. I'm fresh out of answers for that. No offence, by the way.
in relation to temperature sensing,
Yep.
I'm running 2 Davies Craig fans on my radiators, and unlike what they suggest to sense the water temperature, I've got my sensors in through the fins of both radiators.
Yes.
And I found that to be better suited than the one that you suggest by putting it in through the...
Okay.
Now,
Sorry.
have you ever, or are you developing a better sensor than the one that you just put the capillary line
Oh, goodness.
under the tube of the radiator hose?
Yep.
because they leak and they're...
Yep, they certainly do. If you don't put them in properly, you're absolutely right. And to answer your question, yes, there's one, the 0444, which we have here, which will actually drive, got two 40 amp relays on it, will drive two fans. You can either lock, it's got a 5mm probe. You can either do what you've done, lock it into the fins of a radiator, or you can actually put it, well, if some radiators have got a bung in the side, you can put it in the, we've actually got the compression fitting where you can put it into the side of the radiator, or there's an adapter kit here where you can put it into the top radiator hose and actually take the temperature out of the top radiator hose. Or, in actual fact, some people just use the compression fitting and put it into the manifold. If there's a bung in the manifold, just put it in there.
Because I was thinking along the lines of a sensor that you could put into the cylinder head or the block,
Yep.
all like they do with temperature gauges, something like that.
Okay. Very good question. And I'll pull this thing apart. Here somewhere. That's the sensor that we use now. Pass that around if you want it.
I'll come and see you after.
Yeah, it's okay. So it's a 1/4 inch NPT thread, bolts into the block, or bolts. You can basically put it wherever you like.
One over here, John.
Sorry.
John, do you supply any of the F1 or similar Formula Ford engines?
If I told you that, if I answered that question, I'd probably have to shoot you.
Well, go for it.
No. Yes, we do supply electric water pumps to McLaren.
I see you advertise in the English magazine.
Yeah. Look, it's probably no secret now. It goes back a fair while. They come out here every year, and one of the first trips they make is out to Altona North to grab a box of water pumps. See, it's an interesting situation with the development of the Formula One engine. As you're probably aware, you're not allowed. Well, I think they're allowed 3 engines a year. With these engines, they're so highly strung that they actually have to keep coolant going through them when they're out of the car. So they actually circulate coolant, put them in a box, and they circulate coolant at a controlled temperature because they're so. I guess it's the metal, and someone who knows a little bit more about metallurgy than I do. It'll just, if they leave them without any coolant going through them at a certain temperature, it'll destroy them. So I suppose it's a little bit like a pacemaker, isn't it? I mean, pacemaker stops, you bloody fall ass over here. So with these engines, I guess that's what happens. They just, they're such a highly strung engine. So they use our electric water pumps to pump coolant through them between races when they cart engines, or as you know, they cart them all around the world to every race meeting, and that's what they do. So yeah, we're fortunate enough to be supplying those. That's the 115, the little 115 that they use. They can put comfortably in the box and circulate the coolant for as long as they want with a 12-volt battery.
Ladies and gentlemen, a big round of applause.
Thank you very much.
for John.